opportunities of the photons traveling through that filter multiple times. That's called path length amplification. It means that the optical path of the photon does not match the geometric path. And the analogy you can use is if you had a cuvette, if the light came in here and scattered off a particle, scattered off another particle, scattered off another particle, and then made it out, you might think that its geometric path length is L, but its optical path length might be 2L. So what we do is we measure suspensions of, say, a culture in the integrating sphere. And then we measure that same culture on a filter pad in the integrating sphere. And since this has only single scattering and is measuring absorption, we can relate the two. And we can figure out what that amplification factor is for filters. Okay, and we're actually going to make these measurements. We're going to measure the culture. We're going to measure the filter pad. So we can look at those numbers. But luckily, Dariusz Stramski did it for us, and he's really meticulous. I repeated his experiments. I got the same numbers, so I feel really confident in these numbers. And so when we do this, we're going to measure our baseline and measure our sample, and correct for that. We'll get this optical density of our filter pad. Then we're going to apply the path length amplification correction that Dariusz published in 2015, which says that the amplification is raised to some small power of your optical density times this correction. Okay, so we're reducing it by about 70%. And then we compute the spectral absorption coefficient using this equation, where the absorbance is this. I've written this all down. You don't have to worry about this. And so that allows us to measure the absorption, or calculate the absorption from filter pads. Okay. All right. I think we're on to a few slides on absorption meters. But why doesn't everyone stand up and take a breath? Because it feels like it's not very much oxygen in here. Yes. Oh, let's take a break. Excellent. And come back with questions, because we'll have time for questions.